Hi, good afternoon, and welcome to this webinar on a CompoSIDE case study, converting metal structure to composites and laminate optimization. My name is Lorenzo Bossi, the Sales and Marketing Manager here at CompoSIDE, and joining me today is Jonathan Evans, Application Engineer for CompoSIDE.
Hello everyone.
We plan today's session to last just under the hour. This includes time for question and answers at the end of the webinar. However, should you have any questions during the presentation, please do not hesitate to post them as they come. You can access the question panels on the right-hand side of your screen in the GoToWebinar interface. The webinar will be recorded and will also be uploaded to our YouTube channel along with the previous webinars. All participants will also be notified via email once the recording is made available. Okay, so before we start, I just would like to introduce the main questions and challenges that really prompt us to run this particular webinar. So if you're using any metallic structures and you'll be looking or been asked to reduce the weight, improve the structural performance of your products, or if you just would like to simply offer a premium product for some of your clients, it's clear that composites can be a very straightforward way to achieve those goals. We can hear it and read it everywhere. Composites are stronger and lighter, but unfortunately they are also much more expensive. So does it really make sense for you to use them in your products? One approach that is quite widely used in the market is to just take the total amount of material, whether that is weight of surfaces of a given structure, and then get a pricing for similar quantities of carbon of glass. This is otherwise known as the black metal approach, and unfortunately the outcome is almost certainly not favorable to composites, and is also unfortunately wrong for the vast majority of the cases. So this has been said, and having worked now in quite a few projects on this subject, those are really the questions that comes up at the very beginning of the project in order to evaluate whether or not composite can make sense for you. The first question are generally related to the business case itself, and obviously needs to make sense on both a business and a product point of view. So generally speaking, you would ask yourself, how much weight can you actually save with your product? How much stronger or stiffer my resulting structure will be? And the obvious question as well, how much more is it going to cost? Now there are some rule of thumbs that you may use, or you can also look at examples outside of your organization. But are those reliable, and how much do they apply to your own projects? What we really want to show you today is that you can actually answer the questions yourself with far greater accuracy just within CompoSIDE and with a couple of engineering days of work. So if you went through this first process of the business case, you're now ready to fill in the boxes in order to complement the information. You have your metal structure and you're ready to start working with composites. Now the very first question you may ask yourself is, what material should I use? Glass or carbon? What modulus? Why are different manufacturers of similar, just not to say the same material, they have different properties? Now with property comes another problems. They are hard to find and quite expensive. If you're looking at a single bomb testing campaign, you can go from 2,000, 5,000, 7,000 euros. So you actually need to make a material selection even before the testing. But you can't really do the material selection unless you have all the properties. So how can you actually answer those questions? It's a bit of a catch-22 situation, really. Now, compared to metals, composites have much more failure modes, and their performance will vary greatly when the fibers and plies are oriented at different angles. So which orientation should you use? Is there such a thing such as a right laminate? Now so far you've only been looking at just replacing the material itself, but what about the structure? Is it something that you also should consider, or should you just use the same structure and change the materials? And finally, the very last question, I promise, is how can you actually compare the material costs? How much resin, adhesive, cores are needed for your structures? How much of those are going to be in the final product, and how much are going to be wasted during the manufacturing process? So We hope that you're still here, that you haven't been scared off from composites from all those questions. But for as much as we would like to make it easy and simple, there is a much higher degree of complexity for composites when compared to metal approach. But looking on the bright side of things, this is nothing that really you can solve with just a good process in place and some good engineering skills and products. Which brings us to our objectives for today's webinar. In fact, we hope that after today's session, you'll be familiar with at least the process of running an initial assessment of your metallic structure, evaluate a first principle potential for the composite structures, perform some simple but very rapid optimization on the laminate and the fibers orientation, and finally, at the end of this process, output sensitive comparison of material costs, structural weights, and structural performance. All those steps will be demonstrated during the course of this webinar, and all within just CompoSIDE, hopefully showing you that you can answer all of those previous questions with just a small investment in the right tools, in the right time, and in the right engineering skills. And I would like to hear it from John.
Thanks, Lorenzo. Okay, so let's go on to our case study. As you may have seen from the title, we're going to be analysing a lightweight helipad structure, which is portable, so weight is very critical. The baseline structure is made of an aluminium alloy and weighs just over 8 tons. The requirement for a lightweight structure is to reduce the weight for fuel efficiency and also to increase the lifespan from the properties of the materials. We're going to make a few assumptions. So the frame, the loading in the frame is going to be 100% taken from the helicopter, and the helicopter is going to weigh about 3,000 kilograms, landing at a 2.5 G acceleration, so a pretty heavy impact case. So let's go through the workflow within CompoSIDE. Firstly, we have to select the materials. So this is what we do within CMDB. Then we use section space to analyze the 2D section properties and then create those for the 3D section analysis. FE space is then used to create the 3D FE model, where we'll analyze the reserve factors and how it compares with the real-life baseline example. This will create a baseline design to which we can analyze the composite structure to. So let's jump into CompoSIDE. As you can see within CompoSIDE, we have a very horizontal workflow working from materials to reports from left to right. Let's go into CMDB. This is where we need to select our materials. You can see on the left here that I have a selection of many materials, including my aluminium one. So this is the material for baseline design. This is from the CompoSIDE database. We have our material selected, so what's the next step? So let's jump out of CMDB, and we said it was section space, so we need to create a 2D section. What I did was I created, using our template section generator, a basic box beam, 150 by 100. And then I applied this aluminium alloy to it. So as you can see in the stack, I have an aluminium alloy that is 6 millimeters thick. This is the baseline material. So how would we analyze this? We can either analyze it using hand calcs, generate shear forces and bending moments using spreadsheet calculations or just by hand, or we can generate the loads from a 3D model. For this example, let's generate a 3D model and extract the loads from that. So jumping from section space to FE space, saving our section to make sure it's all up to date. We can access all the modules on the left of CompoSIDE. And I have a few products in here. Most of these will be used later. But I have my baseline design, so this is my support frame. You can see it's all web-based, so it's all loading automatically on my Firefox browser. I've imported this geometry as a 3D step file, so I've created it out of CompoSIDE, but you can also use the tools within CompoSIDE to create your geometry in here. I've then analysed this structure under the loading that I said and I've applied my beam sections to each of these beams. Now this may look quite complex, but it didn't take me more than 10 minutes to apply the boundary conditions, loads and section properties once I had the initial geometry. So I've got my baseline structure, I've got my section properties. What do I need? So I need to calculate my structure with my load case. As you can see here, it's point loads on the beams in the center where the helicopter would land, and it's simply supported around the edges as if it was on the ground. So I can calculate this, and what it does, it will send it off to the server, as you can see on the left on the tree. It will take roughly 8 to 10 seconds to calculate, and then it will bring my results back. Now, FE space shows a variety of loads, but at the moment I'm just interested in the strength and the reserve factors that I'm getting on the beam. So if I calculate my reserve factors, CompoSIDE will analyze these and use the section space properties to give me a minimum reserve factor based on the failure mode. So we can see where it is, where it's failing, and the reserve factor. Now I said earlier that we can either bring in the loads to section space manually, or we can bring them in from FE space, which is what we're going to do here. So you can see that I have a very, very optimized reserve factor, 1.01, and I've got the allowable loads, or the actual loads and the actual responses here. I can actually jump back into section space through FE space to review this section. And you can see that it's brought in the loads here, and it's given me where it's failing and the reserve factor. So I'm very happy with my design. I'm happy with this result. I can jump back out of section space into FE space, saving this so it keeps my loads. And I can close this and switch back into editor mode. Now, one other thing CompoSIDE has done is if I want to analyze the weight and the cost of my structure, CompoSIDE automatically works out how much it's going to weigh and how much it's going to cost automatically from this frame. So if we save this frame, we can then jump into our bill of materials generator and work out how much it's going to weigh. So if we jump onto our dashboard again and go into the BOMGen module, you'll see that I have my aluminium support frame. I can update, so it will automatically bring in all of the data that I've got in my FE model, and will give me a design weight and total material costs for this. So I have 0.1 for my design optimization. Okay, so let's jump back into the PowerPoint. So this is step 1 done. I've selected my materials, I've created my 2D sections, I've created a 3D model and analyzed it. And then I've generated some outputs. So I've got my bill of materials, my cost and my weight. The next step we want to do is try and work with composite materials. So for those that aren't very familiar with composite materials, you may be thinking, how do I know which material is best for me to choose? Which material am I going to use first? This is where we can use CMDB to analyze the materials, compare them against each other, and then select one, maybe a low technology one, so we can get a good feel of how our structure is going to respond. Once we have our materials, we're assuming that the sections and the frame doesn't change. So all we have to do is replace the materials in the 2D section with our new composite material, and then update the FE space model to then get some, to validate our section and get some good design data out. From this we can generate the bill of materials and get a good weight and cost. So let's do this. If we jump back into CompoSIDE, so first step, we need to select some materials. So CompoSIDE material database. We have a lot of materials in here, over 1,300 materials, but I've selected a few ahead of this webinar to make things a bit simple, and I've created a material selection out of them. I've also added the aluminium in here. So I've created a selection of carbon plies. You could create glass plies or aramid plies. A selection of quadraxial, unidirectional, woven and biaxial plies. All standard modulus, ranging from 200 grams to 800 grams. And they're all epoxy and all hand layup. So you could do this for any other material. So you could do it for different manufacturing types. So I've gone for hand layup. You could go prepreg, pultrusion, polyester resins, vinyl ester resins, you name it. But we need to know which one to use. So what we can do is we can select them and create a scatter plot. We can use then two properties to then easily select some. So for my example, I've used a tensile modulus, just comparing the metallic to my carbon plies. So ignoring the density, we can just see the tensile modulus ranges from 84,000, 85,000 to 30,000, and my aluminium over here is about 70,000 megapascals. So quadraxial ply will be a very good starting point for this. It's got equal fibres in all directions, so very, very easy to design with. We can get a very good first design out of this. Okay, so let's say we're going to use the quadraxial first. Then what do we need to do? We need to replace our section properties. So for this, we will jump into section space. You'll see that I've already got my quadraxial in my project materials. I had to do that to select which material I was going to use. Okay, so let's jump into section space. We already have our aluminium beam. We need exactly the same beam. It's going to be under relatively same loads. So what we can do here is we can just duplicate it. This is going to produce an identical beam to the aluminium beam. And then we can use the loads that we've already generated earlier to analyze it. So this is our aluminium beam. What we can do is we can go into the stack, remove the aluminium, we don't need that anymore, and add the material. So let's just say we want quadraxial carbon, standard modulus. Let's go for an 800 gram. And let's say, for example, we want 6 plies, and this will be applied all the way around the section. Let's add this in. Okay, so we can save and close. You can see that it's been updated. It's slightly thicker, but how does this compare? So my loads are already in here. This is the load that I created earlier. I can just calculate the load and it will give me a reserve factor. As you can see down the bottom here, it's going to fail in tensile resin failure, and it's got a reserve factor of 1.58. So we have some room for optimization. So I can do a double click on the section, maybe remove a few plies or untick them, save and close, and then recalculate. Okay, so 1.066. We're very close now. So let's say I'm happy with my design. We then have to, our ultimate goal is to get a weight and cost. So we need a verification first. So we save our section, and then exactly the same as we did within section space, we can jump into FE space and replace the section properties with our new quadraxial properties. So I've already done it here to save a bit of time. And you can see that I've already got a few results up in the top here. So I can bring back my results from earlier. I've got my results. I've got my deflection results showing at the moment, and I need to have a look at my beam reserve factor. Okay, so we're failing in a slightly different place, but we're still okay. We're still above 1, which is our design target. Okay. So the same as earlier, we need our weight and cost. Let's save this model And as we've duplicated the product, this will create a different bill of materials, which directly compared to our original bill of materials. So same as before, let's exit FE space and go into BombGen. This is where we have our products. So our carbon support frame with coaxial laminates. I can update these, and this will give me an updated weight and cost. If I've changed something within CompoSIDE, so if I've changed the weight or the cost within CMDB, I can simply bring all that data into CompoSIDE, into the bill of materials, with update with source, and this will just refresh all the data. Okay, so let's see how it compares. Okay, so we've got a weight saving of 43%, which is fairly good, but the cost has gone up quite a bit. So how are we going to reduce this? So we're going to reduce the mass of the carbon, maybe using more higher performance plies, and this is basically optimizing a laminate. So from this we need to select the different fabrics, different plies, and the orientation of the fibres within this. So this is step 3 within the project. So as you can see from the bottom, almost exactly the same as the top one. We select our materials within CMDB. We then replace the material in the 2D section with composites, and then replace the section analyzed with composites. And then we get our weight and bill of materials. So let's jump into CompoSIDE again. So in CMDB again, we go into our material selections and compare them. So property scatter plot, and let's say we want, without the aluminium, we want allowable strength, so compressive strength. Okay, so we can see that we have a compressive strength of minus 191 megapascals, and yet our UD has a compressive strength of minus 525 megapascals. So we want to use that where we've got high axial stresses. And we may want to use a different ply, such as a biaxial or a unidirectional orientated at plus or minus 45 to give us good shear properties. Okay, so we've picked a good material. We've got a unidirectional carbon, and all we need to do now is use this, apply it into our section. So same as before, we can jump out and jump into section space. And exactly the same process as we did before. I duplicated my beam and then applied my different materials. So as you can see in this beam, it's quite thin, but we've got a sufficient reserve factor. So we're a reserve factor of 1.54. I've also done a different, slightly different beam, so I've applied a different laminate to the top and bottom as I have to the sides. So I've got unidirectionals all at 0 in the top to use that compressive stress, and lots of 45, minus 45 in the shear webs, exactly the same as I did, compared the materials with shear strength. Okay, so these walls are looking fairly thin. If I want to do a quick see if they buckle, because they're okay in strength reserve factor, but I'm not sure about stability. What can we do? So we can use FE space to do a quick panel check by extruding the beam directly from section space. This gives us our geometry and our laminates. So I've done this earlier. Let me save this and then we'll jump into FE space. Okay. So you'll see that I have two tasks here. I have one saved as single skin and one saved as sandwich. So this is my single skin. I've applied a shear load to this and I've analysed it under buckling, linear buckling. So you can see that it's going to buckle at the end. So my webs are very thin. I've got a reserve factor of 0.78. So this isn't good enough. What I can do is I can add So I can add thickness to the webs, but I don't want to add too much weight and therefore increase the cost quite a lot. So the other option would be to use a foam core. This is what I'm going to do. So I've selected a 3A T10 foam, which gives me excellent shear buckling results, and it's a relatively thin core. So if I bring up the sandwich results, this new 3A foam has given me a new reserve factor, a new buckling load factor. It's above 1.27 because we haven't got any buckling in the webs up here. So we know that foam has done the job. The only thing we might be worried about is the top of the beams, but we're still above 1, so I'm happy with that. So we've added a new foam, and we've done that within FE space. We now need to get that foam into our bill of materials and our validation, which is our other frame 3D model. So where we defined it in structural elements, we can create the laminate family directly from here. Let's call this shear web laminate. Okay, let's create that. So then this will automatically create the laminate and then bring it into laminate space. Let's save this model and have a look at that laminate. Okay, so we can see the stack up here. Also in laminate space we can check the engineering constants, so the allowable strains and stresses, the stiffness properties, and we can also apply loads here, work out the sandwich stability. Is it going to, what's the local stability of the sandwich like? So you can do fairly detailed check within laminate space itself. But for this example, we're happy with the results that FE space has given us. So we need this laminate to appear in the bill of materials. So let's jump into section space again and go into our beam. We need to link all this together. So once we've defined it in laminate space, we can edit the shear webs, remove these bidirectional plies, and add our laminate family. Now if we change in laminate space, it will automatically get trickled down through section space, FE space, through to the bill of materials. So let's save and close. That thickness is looking much better, and we can calculate the reserve factor from this. Okay, we're fine still. Let's save and close and then jump back into FE space for our validation. Okay, so we mesh the model. This will make sure that the correct properties and the correct material quantities are taken into the bill of materials, and we can then calculate the model. Exactly the same process, just changing around the materials. Okay, so our reserve factors, let's hope they're okay. Okay, we're happy with that. So, we're happy with that. How much is it going to weigh? How much is it going to cost? There's one way to do this, bill of materials generator. So let's jump into our product an update with the source, so this will bring the latest data. And we know that it's going to be, okay, 2.5 tons and 32,000 euros. This is much improved on our original quadriaxial guesstimate. So from the aluminium, we've got a weight saving of 60%, and we've pretty much halved our weight from the quadriaxial. And you can see that it was very quick and very easy to compare the properties of the UD versus the quadriaxial. In terms of the cost comparison, we're still a little bit higher than aluminium, but we're lighter. That's going to save fuel, that's going to save weight, and it's going to last a little bit longer than the aluminium will. So the structural analysis doesn't really stop here. You've still got panels to analyze on top of the structure. We can do this within FE space and do a panel analysis. We can do modal and buckling analysis, or we could check against a different manufacturing process, for example, pultrusion. We could do a pre-preg beams. Depending on your manufacturing type and the types of the fabrics that you use, we can then go on to optimize.
Okay, thank you, John. That's a lot of information, but hopefully we managed to follow. So let's try to look a little bit at a summary of what we've seen so far. So CompoSIDE allows for very efficient and comprehensive workflow within the design and analysis for both the metallic and the composite structures. What you've seen today is that there are a number of modules that are dedicated each to some of the main design steps that you would follow during the process. So you start from CMDB, which helps you to store all the information which is really related to your materials and plies. So you can have physical and mechanical properties that can be stored here and used within all your projects automatically. When you have the pricing information, that can also be included into the bill of materials that are generated later on in the design phase. We went fairly quick over laminate space, but this is a tool that is dedicated to the extended classical laminate theory. It allows you to design and store an infinite number of laminates and sub-laminates to be used again across all your projects. Section space is a beam modeling and 2D section drawing module. So within section space, as you can see, you can import or generate 2D sections and then perform a first principle analysis of your structures, link them to the laminate, link them to the FE structure. So it allows you to really do a quick optimization process. FE space is the module dedicated to 3D modeling and FEA. As John mentioned, you can import files, create your own directly within the module, and it automatically basically generates a mesh for your linear, model, and buckling calculations. The same mesh is then used in order to evaluate material quantities and weights and surfaces using in the bill of material. And finally, the BOMGen is the automatic bill of material generation module. It really does automatically calculate basically everything in relates to weight and surfaces and all the costs for the structures that are defined within your same project. The approach is that of an integrated system. It allows you to make modifications upstream into the project, but also to have those automatically propagated downstream throughout all the following models. It makes it easy and quick to perform multiple optimization loops within the software without having really to switch out to multiple Excel files on calculations or other design softwares. So, if you remember some of the question we asked ourselves also at the beginning of the webinar, we're asking, which material should you use in your project, and we think that CMDB can really help you in the selection of those materials. You can search by properties, you can compare properties, you can export properties as well, also if you're using other FEA solver or other CAD systems. Where can I get the properties for those materials. Well, CMDB has an add-on which provides in excess of 1,200 materials. So we're talking about metals, plastics, plywoods, composites material, plies, that are all fully documented with all the data required in order to run your laminate or your sections or your 3D model analysis. How should I orient my fibers or plies? Well, you can within CompoSIDE do those quick optimization loops. Start with quadaxial if you're not really sure on which direction you should use them, and then you can use the approach John showed earlier to just orientate the fibers, add cores, remove those as needed in order to really compare the two designs in the most effective way possible. And how can I compare the total material costs? Well, as you've seen, BOMGen automatically provides you those costs and weights based on the structures you have. And what is interesting is that, as you can see, if you just replace materials, without that, let's say, couple of hours of engineering work, you may find yourself in a position in which your weight is still the double of what it could be, and your costs are still about 5 to 6 times higher than the original structure, whereas minimal engineering science can actually bring those down to much more realistic values, so lowering cost and lowering weights farther from just this initial design approach. But here in CompoSIDE, we actually think that the best case is to look at it for yourself. And the good news is that we actually offer what is a 30 days free trial straight up from our website. Registration takes only a couple of minutes. There is no software to download, so you can be up and running within 5 minutes from the moment you sign up. The trial is pretty much an ideal way to replicate the workflows we've shown today, or even look at your own case. John, myself, and our other colleagues are available during the duration of the evaluation period to also help you carry forward your designs. So we're here to support you with the design cases you need. So I mentioned with the trial you do get access to dedicated online help and support, video tutorials to get you started, live chat with our support engineers straight from within CompoSIDE for when you're stuck, email support, FAQs, and webinars also available to answer some more specific questions. Alongside the services, there are also dedicated online training, on-site training, or bespoke engineering services if you feel you made the first steps but would like our dedicated help to continue in your activities. Just let us know what your objectives will be, and we'll suggest some of the possible solutions to move ahead. So this brings us to the question and answers. So there are a few questions already, but if you have any, please do continue to type them in to the questions panel. That will be on the right-hand side of your GoToWebinar interface. So we'll just come back in a minute after we review some of the questions. Okay, so there is a fair question that asks, if I've done my initial analysis in CompoSIDE, can I use the same materials in FEA? John, would you like to comment on that?
Yeah, absolutely. So we do support material export, which gives you this full design data into ANSYS ACP, OptiStruct, Nastran, or just a material, an Excel export. So once you've done your initial analysis in CompoSIDE, you can then use this alongside another package, which saves you a bit of money, so you don't have to do all your analysis, buy a few licenses of that other program. You can do your additional non-linear analysis, for example, within your preferred solver.
There is another question in regards, is more on the import side, what files can you import into CompoSIDE? Moving from section space, DXF, Excel, basic 2D files definition, step files primarily for FE space, so you can bring your models in, allocate the material mesh and review the results really.
Yeah.
Here is an interesting question: is why are the materials marked generic? Shall I? Or?
Yeah, you can.
Yeah, okay. It's a very good question. So I mentioned earlier there are roughly 1,200 materials in CMDB. And we actually said earlier as well, it's fairly difficult to get all the properties you need for design and FEA purposes. There are multiple reasons. One is because there are no predefined standards. When we compiled the database, the metals were very easy to insert because there's a well-defined standard that says this material, those properties. But when you're working with composites, you have your fibers, your resin, your adhesives, your cores. So whenever you're looking at it on a single ply, you may have so many variables coming in that makes it difficult to have all the data required. Now, furthermore, the test results may change according to different manufacturers, different testing processes. So there is really not one single set of value from even a single manufacturer. So what we've compiled them as generic, it means that those are the values, those are characteristic values for the given materials that you can use in all your design and analysis purposes. And whenever you are a phase in which you need to get the whenever you're in a phase in which you need to get the actual material costs, then we are confident that you can actually find these material properties within the marketplace. Okay. Next question. There is a question whether we had academic licensing. We do, yes, it's not through the web, but you can just write to sales@composide.com, and we're basically answering in regards to the options available to your academy or your faculty. And a similar question on the annual licenses. Well, CompoSIDE is a subscription level, so you can either subscribe monthly or annually. When you go annually, you really have 2 months free as part of your commitment and your engagement. So yes, you can do monthly just to start your evaluations, or annually if you'd like it for a longer period. Well, good spotting on this one. Someone noticed there were a few more modules in CompoSIDE than what we've seen today. That's true. We have the dashboard is basically your administration panel. You can log in, well, you basically log all the information dedicated to the users. So it's a multi-user, multi-project environment. But you can also store project information like specific amendments to the bill of materials and things like that. Project space is the project. Maybe it's easier if we just go back to this one. So project space is the module dedicated to the management of your projects. So you can allocate which users are dedicated or allocated to work on that same project. We say it's CMDB materials, laminate space, it's self-explanatory, section FE space. YachtsCant is a module dedicated to the marine industry that allows to automatically output reports for the ISO and GL vessel certification organizations. So it follows the same principle of integration. And BladeScant is dedicated to the wind or tidal turbines blade design, which are primarily made of composites. And finally, a link is our module dedicated to linking with various FE solver and CAD solvers. We haven't explored that today, but there are a number of options. So John mentioned you can export laminates, materials, plies, and laminates to ANSYS, Altair, OptiStruct, Radius, alongside Excel for whatever you need. We also have an API that you can use in order to read the material data or laminate data into whatever other software you're using yourself today, or for automatic optimization loops as well. Okay, so I think that's pretty much it for today. If you have any further questions, you can write at support at CompoSIDE.com. Yeah. That's more for the technical aspect. For sales-related inquiries, sales at CompoSIDE.com. We'll be happy to just follow on your inquiry and try to answer as quickly as possible. Otherwise, we hope that has been interesting. Thank you for your attendance and participation today. If you'd like, I invite you to try the software out yourself. That's honestly the best way, and see what it does, and we'll be happy to help and support you throughout the process. Okay, thank you very much.
Thank you.